Morning. My name is Murali and KRISHNAN. So now I'm going to say about the introduction. Managing urban traffic flow is a major of challenge in the modern cities, demanding efficient and reliable system. The smart traffic control system address this by using real-time data and optimize signals instead of fixing times. This report examines the systems engineering principle, highlighting the microcontroller's role and use of functional programming in C to ensure modularity and reliability. It also evaluates the design in terms of public safety, sociality, and environmental impacts. The objectives are: first objective, student can learn to identify the system architecture and specify its hard real-time requirements. Second is student can learn to demonstrate how the function programming paradigm in C used to recreate modular and reliable embedded code. And third is a student can also learn to synthesize the report's findings to draw a strong conclusion on the system success and its broader engineering implications. Now we're going to see about the microcontroller role. The microcontroller or MCU, example Arduino PIC or 8051, is the brain. Continuously reads input from vehicle detection sensor like inductive loops or precision push buttons. It executes the control logic or state machines and sends output signal to the light bulbs or LEDs to change color to the red, yellow, and green. Real-time supervision. It must to handle interrupts from sensor to intimately adjust the timing or to ensure that yellow light's duration is precious. Thank you.
Hello everyone, my name is PAVITHRAN like SATHASIVAM. My metric number is 141023 F1023. Okay, I would like to talk about today's programming in key. So this slide is explain how to see programming language to control a traffic light system. We implement the final state machine or FSM, which help to manage the sequence of the light green, yellow, and red, and their timing. Each light is considered a state, and the system moves from one state to another state a fixed time delay. We use C programming because it's a low level programming language that can directly control the microcontroller hardware pins and timing function. The delay function like ensure that the light stay on the correct duration, which is important to real time operations, meaning in the program react in the charges exactly at the right time. Okay, we move on to the next slide, which is G code structure. You can see the example in the slide. So this code structure for use in traffic light control. First, we define the possible state using an enum, which represent red, yellow, and green lights. Inside the function, the program continues to check with the state of active using a switch case structures. Each case has three parts. Number one, turn on the correct light using. Number two, wait for a specific time using, for example, for 40,000 milliseconds for 40 seconds for it. And third is move to the next state after the time is delay ends. The structure repeats continually, forming a real-time cycle, and the delay makes sure the each light stay on for the correct amount of the time. This is what makes a real-time embedded systems. Okay, now we move on to the next slide. You can see the two image. One is a car with a multiple sensor, for example, like laser, radar, ultrasonics, and camera. Second image is a traffic light diagram showing a stop for red and wait for yellow and go for green. Okay, the visual shows how the system works in the real world. The modern smart traffic light system can include sensors like ultrasonics, radar, camera to detect the presence of vehicles. These sensors are sent to data to the microcontroller, which decide when to change the lights. For example, if there is a no guard detect on the side, the system can shorten the green light duration that lane to improve the traffic flow, reducing waiting time. On the right side, the traffic light diagram represent how to see program cycle through the states: red, yellow, and green, just like FSFV code.
Hi, my name is SUHEN MAGENDREN. My memory number is 141023F1011. Today we are going to focus in considerations. First one is public health and safety. Primary focus: the system is essential for preventing accidents and ensuring the safe flow of emergency vehicles. for example by giving priority using a special sensor input. Second one is societal. It reduces traffic congestions, lowers stress for commuters, and can be optimized during peak versus off-peak hours. The last one is environmental. Is optimized flow reduces vehicle idling time, leading to less fuel consumption and lower CO2 emissions. Next one is conclusion. Conclude that the system effectively meets its objective by providing safe, optimized, and reliable traffic management through its hard real-time processing capability. The embedded approach allows for flexibility, for example, adapting to traffic density while ensuring high reliability. The references we got 5. First one is microcontroller datasheet. Second one is embedded C programming text. Third one is real-time system design text. Fourth, traffic management standard. Then last one is technical article. Thank you.